Hi, if you're here again, maybe God has given you wisdom, maybe from your family, maybe from your friends, or might any outsider. Right, today we're gonna talk about inductor. Basically, what is inductor in simple words, right? Basically, it's just a passive two-terminal electronic component that stores magnetic field, energy in magnetic field, which when electric current move through it. Okay, there are two types of inductor, which are air core inductor, it wound on non-ferrite core, and another one is iron core inductor, which it was wound on ferrite core. Air core inductor, as we know, air core inductor basically just wound on non-ferrite core, which is non-ferrite material. The core is completely ambient or ceramic in use. It has low thermal expansion or coefficient. Normally used in high frequency applications such as TV and radio receiver as well. The second one, which is iron core inductor, which is wound on ferrite core. Just a fixed value of inductor which is kept between the coil. The iron core inductor basically is just for filter out the circuit and smoothing out the ripple voltage. Normally used in fluorescent tube light, in industrial power supply, and inverter system as well. How is inductor work basically? The coil which carrying the electric current basically just induces the magnetic field around the conductor. The intensity of magnetic field increases if the core is placed between the coil. The magnetic field induces EMF in the coil, causing electric current. The inductive reactance increases as the increases of number of coils. EMF is known as electromotive force. EMF basically flow against the current, which I'll be explained in the theory and calculation section. Fun fact here is basically you can create an inductor just by using copper wire and iron core, and you just wrap around the iron core. It will create a magnetic field, which I will be shown here. So here is the iron. Just wrap around here. You might just get a inductor here, just like this. Okay, to make an air core inductor, right? So basically, to make an iron core inductor, you have to have much thickness, which is at least around 18 SWG or thicker for the signal current. So the copper wire is much thicker, should be much thicker for the iron core to have inductor. Alright, so basically what I'm making here is iron core inductor. So in this case, this is just a demo for me to show how to make a inductor here. Okay, done with it, we go to the basic theory and calculation section. Alright guys, let's do some theory section about inductor here. And the inductor symbol basically is look like a resistor with upside down in the half circle form repeated. And the inductor unit is Henry. Here shown that it is for Ohm's law for inductor, which is V equals to L times di over dt. V is whereby is the instantaneous voltage across the inductor, L is the inductance in Henry, and di over dt is rate of current change. Alright guys, so we're gonna do 3 questions about theory here. Okay, we started off with the first one, which is okay, a current in a 30 millihenry inductor changes from 12 ampere to 28 ampere in 125 milliseconds. So what is the magnitude and direction of the induced EMF in the coil? To find what is the induced EMF, right? Let's start it here. The induced EMF formula is what we use here is induced EMF equals to negative inductance of inductor times the difference in current and the difference in time. Alright, this is the formula for inductance of induced EMF, and this is inductance of inductor. Let us list here all the traits of the properties here. So first, this is induced EMF. Alright, this is induced EMF. Then there is this L, which is inductance of inductor. Then we got the difference in current, and difference in time. Alright. Alright, so we're done with the formula here. Proceed with the calculation. Shown here is that a current in a 30 millihenry inductor changes from 12 ampere to 28 ampere in 125 milliseconds. This is the inductor. Let's say this is the inductor. We know that current is moved in this way. Induced EMF is moved this way. So we have to find what the induced EMF here, right? Let's calculate here. Induced EMF equals to negative inductance of inductor times difference in current over difference in time. Okay, let's calculate this. Alright. Negative 30 millihenry times with the current, difference in current, which is 28 ampere minus 12 ampere over difference in time. Difference in time is 125 millisecond. So it's 125 times 10 negative 3 because it's millisecond here. So equals to, let's calculate, 30 shift milli times 28 minus 12. Alright, hope you can see this, equals to 0.48 divided by divide by 125 times 10 negative 3. So I get 3.84 volt induced EMF. 3.84 volt. So we just, let's say, just round off, so we got 4 volt induced EMF. But you can see here is this is the induced EMF direction, which is moved against the current direction, which is here. It become, the induced EMF is become negative 4 volt here, shown that like that. Alright, okay, we're done with the first theory question. Let's proceed to the second theory question. Okay, welcome to the second theory question here, which we stated here is a 50 cm A field solenoid with a diameter of 10 cm, which has a turn of 800 turns. Let's calculate the self-inductance of this inductor. Stated here is this is the air field solenoid, right? Okay, this is air field solenoid here, which we have the length of, this is the length, and this is the diameter, right? Each is stated here is diameter for the wire. We have to find what is the radius. We know that diameter is 10 cm here. Radius is just divide by 2, so become 5 cm. Alright, and you have to convert it to meters. It's 0.05 meter. So let's get to start here. We have to know what is the self-inductance of the this inductor. Alright, of this inductor. Here is stated inductor equals to, this is the formula, N times magnetic flux over current. Alright, also known as equals to N times magnetic field times area over current. So this is also the formula, which is the self-inductance of the inductor. Right? Know that magnetic flux is equals to magnetic field times area. Right? Magnetic field, there's another formula for it. Alright, magnetic field equals to mu, which is the permeability, times number of turn times current over length of the length of the inductor. Alright, how long is the inductor is shown there. You know the permeability of free space, which we know as constant, is this is equals to 7.854 times 10 negative 3. Okay, this is the permeability of free space, which is the constant. Alright, it is stated as constant, which stated here is the free space for the inductor here, right? Okay, it's like this. This is the magnetic field here, so it's the free space of the inductor there. So we know this one is the constant for the inductor. Alright, so this formula here, this is the formula one here, right? Okay, let's use the formula here and combine it as one. Alright, know that inductance of inductor equals to number of turn times area over current, which is this, and we know which is this. We substitute this formula to here, so we will get permeability times number of turn times current over length of the inductor here. What is stated here is basically we substitute the magnetic field formula in here to calculate the self-inductor for this solenoid. Alright, inductor of inductor equals to number of turn times area over current times permeability of free space times number of turn times current over length of the inductor. So let's times here. So we know that, let's cut this off because it's current at the top and current at the bottom. We just can cancel it off. Number of turn times area times permeability, alright, times another n over length. What we get here is permeability of free space n square, which we got 2n here, times a over length. So this is the formula we'll be using to calculation for the self-inductance of the inductor, which for the solenoid. Alright, basically what we do here is just substitute all the formula into one formula. What is the properties? Let's say this is magnetic field, magnetic flux, so you have to know each one of the properties here. Alright, okay, so let's calculate this. L equals to permeability of free space, we know that is 7.854 times 10 negative 3, which is the constant, times number of turn, which is 800 square, and times with the current. Alright, okay, in this case current we don't know yet, so we have to calculate what is the current basically. Oh sorry, what is the area? It's not current. Okay, so it's A, we have to calculate here. A equals to pi r. We have to calculate what is the area here, so A equals to pi r square. Alright, pi r square equals to pi r square, which is 0.05 square equals to, okay, let's calculate. Shift pi here, right, times 0.05 square. What we get here is 7.854 times 10 negative 3. So this is the area here. 7.854 times 10 negative 3. This can substitute into the here, which is the formula. 7.854 times 10 negative 3. Alright, and we divide by, which is the length is, what is the length? So it's the length is 0.05 meter. Right. Okay guys, it seems that I'm mistaken here. Permeability of free space is not 7.854 times is. Alright, let's cancel this out. Basically is mu permeability equals to, which is 4 pi times 10 negative 7. Alright, this is the permeability of the free space. Alright, here. Not this is a mistaken here. So let's cancel this out. So is 4 pi times 10 negative 7. Okay, this is the permeability of free space formula. Okay, let's calculate this. 4 pi times 10 negative 7 times 800 times 7.854 times 10 negative power of 3, and then we divide with 0.05. Okay, actually it's not 50 cm here. This is 50 cm convert to meter is 0.5 meter. Alright, which is 1, 2. Alright, so it becomes 0.5 meter here. Let's write these things again. Permeability is equals 4 pi times 10 power of negative 7 times 800 square, that we times with area, which is 7.854 times 10 negative 3 over 0.5 meter. Okay, so let's calculate. 4 pi times 10 power of negative 7, 800 square times 7.854 times 10 negative 3. Alright, we divide by 0.5. Alright, so we got 0.0126 Henry. So let's convert it to millihenry here. Become 1, 2, 3. So it's 12.6 times 10 negative 3 Henry. Get 12.6 millihenry for the inductor, for the solenoid here. So we get 12.6 millihenry for the self-inductance for the inductor. Alright, let's proceed for the last theory section here. Okay guys, so this is our last theory section here, and theory and calculation, sort of calculation section here. What is stated here is a toroid solenoid has 400 turn with a radius of 30 cm and a square cross section with side length of 5 cm. So let's calculate the self-inductance of this toroidal solenoid. Okay, toroidal solenoid basically is like okay, I will show you how is it. Hold on. Okay, toroidal solenoid basically just a ring. Alright, you see this is the ring, right? You can find the which is the real toroidal solenoid. So it just is a ring, but erupt up with the copper wire, so it become toroid solenoid. It's actually a ring wrapped up with copper wire. Okay, let's proceed the question. Okay, let's list out the formula here. Inductance of inductor L equals to number of turn times magnetic flux over current. We know the magnetic flux also can be known as magnetic field times with area over current. Alright, we list out here. We can take out the magnetic field here times magnetic field. Magnetic field also known as permeability of free space times number of turn times current over 2 pi r. So this is the one formula. This is one other formula here. Magnetic field formula, alright? This is self-inductance formula here. Know that how is I already shown which is a toroid of solenoid. Basically it's just a ring here which wrapped with the copper wire, alright, which I shown just now. It's just basically a ring wrapped with copper wire. It's stated here is the side length is 5 cm, so it's basically here, which is the, let's say, the cross section for the toroid solenoid. So we known here is 5 to 5. Basically what is the area for the toroid solenoid? Side length of 5 cm. Alright, 5 to 5. 5 to 5 cm, we convert it to meter, so it's 0.05 meter. Alright, okay, so we know that inductance of inductor equals to number of turn of the coil times area over current times permeability of free space, which is here, times number of turn over times current over 2 pi r. Alright, so just cancel this out. We get number of turn times area times permeability of free space times number of turn, another here, so we get 2 pi r permeability of free space. Permeability of free space times n square times area over 2 pi r. Basically it's just this formula. So I just substitute all the value into this formula here. It's equals to permeability of free space, we know that is equals 4 pi times 10 negative 7. Alright, so I just substitute in. N square is number of turn, you know that is number of turn is 400 square. Meter is 0.05 times side length, which is for the area here, so I just times for the 2 here, side length, over 2 pi and r. R radius is 0.05 0.3, radius of 30 cm. We just convert it to meter. cm equals to 0.3 meter radius. Okay, let's just calculate this. 4 pi times 10 negative power of 7. 4 pi times 10 negative power of 7 times 400 square times 0.05 times 0.05. Alright, so we divide 2 pi with 0.3. Okay, got this. I'm not sure you can see. And we got this. So it's equals to inductance of inductor is equals to 2.67 times 10 negative 4 Henry. So also known as 0.267 millihenry. Let's recap what we have learned here. We can write it back, right? Let's recap. Okay. Here's a blank page. We know L is self-inductance of inductor. We know N is number of turns. We know mu note here equals to permeability of free space. We know here diameter is D is equals to wire diameter. We know this symbol is for magnetic flux. This is for B is for magnetic field. And last but not least is A, area. Basically this is what is the formula, which is the symbol for each formula important for the inductor. Alright guys, that's kind of basic content for the inductor. Maybe in the future content I will further explain about inductor in much depth and details. Don't forget to press the like button and subscribe for my future content. Press the bell notification below so you will be notified when I release any new video. Okay, that's all for me. See ya in the next video. Bye.